Hi, my name is Manish. I am going to present the simulation of hot rolling process two stage. This is the schematic of hot rolling process. This is the furnace from where the stock is coming out, and this is the descaler, and this is the rolling, the rollers. Now the stock will pass through this both. First of all, it will pass through the descaler, and then it will pass through the rolling rollers. Again it will pass through the descaler, and again it will pass through the roller. This is a two stage rolling process. Now these are the process parameters which I am going to use in my simulation. So these are the some process like initial thickness of the plate, it is given, thickness at the end of the first stage is given, roll diameter, roll speed, friction coefficient, descaler, contact conductance, initial length of the stock, convective heat transfer coefficient, initial temperature of the stock, initial roll temperature, ambient temperature, distance double by stock, distance from center to of descaler to center, length of the descaling unit is 80 mm. These are the process parameters which I am going to use in my Abaqus simulation. So let's go in the simulation part. So this is the overall view which I had already done in my Abaqus software, and this is the uh, stock part where my cursor is rolling. After that descaler part is there, that is rp1 reference point 1. Then roller is there. Then second part is the uh, descaler, and again roller is there. Now we will start from the start. So this is the part. So here I had drawn a descaler like this. It doesn't matter whatever the shape of the what is the shape of descaler, but as per given in the question it is 80 mm length, so I had taken 80 mm length, and arbitrarily I had taken 10 mm thickness. So for part we will go for part manager, and see here we had done the descaler, roller, stop. So like this descaler I had made, roller I had made, and stock I had made. So these are the three parts which I am going to use in the Abaqus simulation for the hot rolling process. Now second is the property. We have to assign the property to all the parts. Now first is stock. For stock we had given the, we have to first make the material manager. So roller material and stock material. So let's see the roller material properties. Like I had taken the conductivity, density, elastic, and specific heat of the roller material. After the uh, stock material, I had taken conductivity, density, elastic properties, expansion value, expansion coefficient value, elastic heat fraction, plastic properties, and specific heat value. After that, we have to we have to use assign means we have to make a section manager where we have to assign section like descaler, roller, and stock. Let's see stock in a like stock. I had taken the section manager, and I had given the stock material as the material here for the stock. Same for all the other three. After that, we have to assign the sorry. After that, we have to assign the section to the for this parts. Like for this stock, I had taken the stock section. Similarly, for roller, I had taken the roller section. I assigned the roller section. Now after that we will move to another module like assembly. So here we will assemble all the parts as per the schematic shown in the that PDF. So we have here first which is which is around 13.7 meter away from the first roller, and the distance between these two is given in the PDF. So as per the PDF schematic, we will arrange the roller, descaler and stock. Our next module is step. So in step, first we will go in step manager and we will assign the step 1, step 2, step 3 and step 4. Step 1 is till my stock will get engaged with the roller. Step 2, when the when my stock is getting rolled inside the roller. Step 3, from when it come outside and it will go to roller number second, and step 4 is rolling inside the roller number 2. So these are the time which it will take, which we had calculated manually and assigned in the software. Now after that we have to define the field output. So field output, we have to see here. We have taken the interval 1000 uh, to store the data, and here some data are selected. For this presentation we had selected the reaction forces and reaction moments so that we can find out the separating force and torques. Coming to next, we will see the field output, history output, sorry, and then we will see select here and we have taken the interval 200. After that we will move to next module. This is interaction module. Now we will here define the interaction between all the parts, like we will define the interaction between stock and descaler, stock and roller, means how the interaction between these two surfaces will take place. So like here we can see I had defined so many interactions, like a roller stock interaction 1, roller stock interaction 2. Interaction 1 is related to your first rolling, roller and stock, and roller stock interaction 2 is related to your second roller and the stock. Similarly, stock descaler interaction 1 and stock descaler interaction 2. Similarly, we have to define the stock convection and stock radiation. Similarly, we have to define the roller convection, roller convection for both the rollers, that is 1 and 2, and roller radiation for both the rollers, that is 1 and 2. So these are the properties. Let me show you. So their film coefficient we have taken 0.085, and this is type of surface film condition. Sink temperature 40 we have taken. Similarly, for radiation we had taken emissivity 0.83, and this is a type of surface radiation, and ambient temperature is 40. Now interaction, let's see the roller stock interaction. Now here we have taken the penalty contact method, and we have defined the roller stock interaction property, which we will see in another icon also. So stock descaler property, here we had taken defined the stock descaler interaction property. Now coming to next, interaction property manager, which we had seen in the last dialog box, that roller stock interaction property we defined here. Now we can see what we had taken here, like tangential behavior, normal behavior, thermal conductance and heat generation we had taken here. Similarly, for stock descaler property, like interaction property, we had only taken the thermal conductance here, because descaler and stock only some thermal contact is there and nothing else is happening there. After that we have to take the constraint manager. So in starting, when we had defined the parts, that time we had taken all the parts as deformable, but here we had what we had done, we had defined the roller rigid, all the rollers and descaler as the rigid body. Now coming to next that is uh, load module. Now here we can see, so first of all we will see the boundary condition manager. We will define the boundary conditions for this rolling process, where we had taken the descaler and we encasted it. That is, let me show you. So see, here we had encasted all the movements. Similarly for the descaler second part. Now coming to descaler temperature, we have to define the descaler temperature, uniform temperature, that is 48 degrees Celsius, both for 1 and 2 descaler. Now we have to define here, give the boundary condition as roller angular velocity, which we had taken as 1.82 for both the rollers. Now roller translation, we have to lock the roller translation in U1 and U2 direction for both the rollers. Now this is the symmetry condition, where that is uh, the movement will be blocked, that is 0, displacement will be 0 in the y direction. Then we have to define the stock velocity, that is when it is in step 1. Step 2 it is deactivated, because in step 2 through the roller it will get suppressed and it will move forward. Similarly for stock velocity 2, that is in created in step 3, and step 4 it will move automatically with the help of roller. So let's see the predefined fields. Predefined fields are roller initial temperature, we have to define here, which is around 70 degrees Celsius, and roller initial temperature 10 second, that is also 70 degrees Celsius. Here everything like I had mentioned, one is for the first part, that is descaler 1 and first roller, and wherever 2 is written, that is for the descaler 2, that is reference point 3, and roller 2, that is reference point 4. Here one thing more I want to tell you. Okay, manager. So this is the stock initial temperature. Stock initial temperature is 1100 degrees Celsius for this. Now, one thing more, to define the boundary conditions, we have to take the reference point in all the uh, parts. Like for D scalar, I have taken the reference point. I will zoom it and show you. Zoom it and show you. This is the D scalar, and I have taken here the reference point for giving the boundary conditions. Similarly, for my sorry, for my roller part, I had taken the reference in the center point to provide the boundary conditions to my roller and the descaler. Now coming to the next module, that is meshing. Here we will use the controls to mesh the to give control to provide the meshing quantity, meshing structure, and then after we will do the we will provide the element type. Sorry, now the program is already running, so that's why it is showing, it is not showing. Then after that we will seed the edges. Okay, it is again it is showing, because the same now the program is running right now, so already it has completed the for 7.5 seconds. The total is around 22 to 23 seconds, so it will take around 1 hour. So let me show you this part also. So this is the program running, this is the total time, stable time, kinetic energy, and this is total energy. So this is the increment taken. Let me show you the data file. So this is the data file, and now we can see the number of nodes also here. This is the problem size. Number of element is 440. Number of nodes are 728. Number of nodes defined by the user is 720. Total number of variable in the model is 2184. Okay, so let's proceed. So here we will first control, then we will give the element type, that is C480, and then we will provide the edges, and then at last we will mesh the part. Here one problem, here one option will come here in the place of instance the part, then we will mesh the part, then it will come. So here I had taken the 100 divisions of uh, this roller. Similarly for descaler, it is not required, but to take the interaction between the stock and the descaler properly, we had give mesh this part also. And stock we can see here. Here there is a stock. So stock it is uh, like this. And in the part I forgot to tell you one thing, that this is the curve in starting of the stock. This we had taken because uh, during the during when the stock is entering into the roller, so what will happen if it is thicken here, means width is more, then what will happen, the crushing will take place. Okay, so to avoid that crushing we will means we will gently uh, make the surface little bit slant. So this is the uh, meshed part. Let me check again whether we can do it or not. Yeah, again like we had taken the element shape quad, and technique is structure here. And after that we can mesh the part, see the element type also here. Like we have to select the region to give the element type. Now the program already running, so I will not select. Seed, we have to seed the edges. So we had taken here, like thickness wise I had taken the I divide the four parts. And in horizontal wise, uh, I think I had taken the 10 is the size of my these blocks, meshing blocks node, which which we can tell as element. Okay, so let's move to next part, that is job. Now here we have to, let me show you, like this is the final part, after the which we have to run the job. For that we have to create the job here, and then we will select we will create here job. Like already one job is running, so I will not run again one now. So it will come here, and like this is the one which is running now, so I can show you what are the things I had taken. So parallelization, I had taken the 8 cores here so that it can run little bit fast. So after taking 8 core also, it is taking around 1 to 2 hours around to run the program. Now precision, to take the um, higher values of decimal places, we have taken the double analysis packager, that is this one, last one. Now after that, uh, after some editing or checking all the values here, we will submit the job, and then the this type of monitor will come. So this is the type of monitor will come here. We can say in log, it will show the submitted time, then started, then completed, and start. So as it will start, it will show some numerical numbers here in the upper side. So now it has completed only 9.45 seconds, but it has to go more. So let let it be running. Let it get running. So we can see the results also in running, like for 9 seconds we can see the results. So let's go plot contours on deformed shape. Okay, so let me bring the frame selector here. So already step 1 is only running. There are 4 steps. So this is the step 1. Now you can see that my stock, this is my stock. So this is my stock, and it is running. So let me show you the temperature. So this is my descaler and this is my roller. I think it has not reached the roller because already now only the step 1 is running. But we can see here that it has passed the descaler part. So let me zoom it and show you. Okay, so this is the temperature and this is the, so let me show you. So it is going slowly. So we can see here that temperature is changing here. Okay, so this we can see here that it is turning yellow. So this means that my descaler is working properly. So now let it run, so that after that we can take out the data from the following. So how to take the data from this? First of all, we will go to tool, then we will go to XY data, and here we will make the create option. From here ODB field output, then we will go continue, and then we will decide the unique nodal we will take, and then we will go for reaction forces, and then we will take the RF2. RF2 is our separating force which we have to find out here. Then we will plot this. So I will not plot it now because the simulation running is not over right now. So this is the separating force, and for torque we will take the RM3 reaction moment. So after that we will plot it in the unique with taking the unique nodal, and we will select the element node here. Like edit, we will go edit selection, and we will select one node. Like for roller we will select the center part, that is reference point 1 for roller 1, and for roller 2 we will select the reference point 2. So like this we will take the torque, and we will measure the separating forces. Similarly for temperature also we will select some nodes here, like one for top surface node we will select the top node, and for mid plane we will select the mid plane node. So this selecting node, and then we can plot the uh, graph as per the time, how the temperature is changing with the time in the descaler, from descaler 1 to roller 1 and descaler 2 to roller 2, something like that. We can find out the temperature of any nodes in the stock with respect to time. So this is the complete video, and after completing this, after the running of this or complete video, I will plot the graphs also, some of the graphs, and I will also post that part also. Thank you.